He claims that CERN destroyed the universe during recent experiments, which has resulted in us living in a nearby parallel universe. The European Centre for Particle Research, CERN, is unveiling details of a new particle accelerator today, something 3 times larger and twice as deep. For many years, scientific exploration has been exceeding expectations and surpassing barriers, from the creation of the Large Hadron Collider and James Webb Space Telescope to discoveries like the Higgs field and the Higgs boson. Scientific advancements can only get better. While the world is facing news of an impending Third World War and struggling amidst serious famine in many countries, the European Council for Nuclear Research has broken its silence on a very chilling discovery that just might change everything we know about matter and outer space. To make matters worse, there is the belief that the discovery is only the Mandela effect and it probably doesn't really exist. But what if it's actually true? What is this scary discovery and why are scientists very worried about it? Sit back as we take you through all that has been happening at CERN recently and what they've discovered. CERN, also known as the European Organization for Nuclear Research, is a place where scientists conduct amazing experiments. It has been around since the 1950s and has helped us understand the universe better. However, some people are concerned that these experiments could create things like black holes or mess up our reality. One of the most famous things that CERN has made is the Large Hadron Collider, or LHC for short. It is the biggest and most powerful machine for studying tiny particles in the world. The LHC started working on September 10, 2008, and it remains one of the most amazing machines scientists have ever built. The LHC is a big circular tunnel that's over 27 kilometers long. Inside the tunnel, special magnets and devices help speed up particles. Building the LHC cost more than $4.5 billion with a production budget of $9 billion. One of the more shocking things scientists found with the LHC was something called the Higgs boson. This tiny particle helps explain how other particles get their mass. The LHC has also helped scientists find lots of other particles that were previously unknown. All these discoveries are helping us understand how the world works better. Here's how the LHC works. Scientists speed up different particles and then make them crash into each other with a lot of force. The LHC can make particles go very fast, almost as fast as light, and they go around the circular tunnel more than 11,000 times every single second. Despite its groundbreaking discoveries and contributions to our understanding of the universe, the experiments conducted at CERN, particularly those involving the LHC, have raised concerns among people across the globe. The fear of unintended consequences, such as the creation of miniature black holes or the disruption of the fabric of reality, has led to debates about the risks associated with CERN's experiments. However, scientists at CERN continue to conduct research responsibly, taking into account all safety measures and regulations to ensure the protection of their experiments and avoid adverse effects on the world at large. The Large Hadron Collider is a massive machine that scientists use to study tiny particles. It works by speeding up these particles fast and then smashing them together. To speed up these particles, the LHC uses something called electromagnets. These electromagnets create a super strong magnetic field inside the machine. In fact, the magnetic field inside the LHC is almost 1,000 times stronger than the Earth's magnetic field. Now, all this power might sound a bit scary, especially for things like electronics nearby and even the Earth's own magnetic field. Some people worry that such a strong magnetic field could mess up electronics or even affect the Earth's magnetic field. Once these particles inside the LHC reach their top speed, they crash into each other with high force. When this happens, it releases a huge amount of energy and creates all sorts of different particles. When these particles eventually crash into each other, they shoot out in all different directions. However, most of these particles only last for a tiny bit of time before they disappear. To find out what happens when particles collide, scientists have placed supersensitive detectors all around the places where the collisions happen. These detectors are like super-powered cameras that record everything that happens when the particles crash into each other. However, all this smashing and crashing creates a massive amount of data. Every year, the LHC produces more than 15 petabytes of raw data. Sorting through all this data takes a lot of time and effort. In 2017, the LHC reached a very important milestone. It stored more than 200 petabytes of data in tape libraries. This means scientists can study all the data from the LHC's experiments in very fine detail. To help you understand just how much data the Large Hadron Collider generates, let's put it into perspective. 1 petabyte of data is like having around 250,000 movies. But why do scientists need so much data? They are looking for something very special in all of that information. Scientists detected something strange happening with a tiny particle called a quark. Quarks are like the building blocks of everything around us. They come in different types, which scientists call flavors. However, some of these quark flavors are very unstable. They quickly change into other particles. One specific type of quark, called the beauty quark, caught scientists' attention. This quark is supposed to quickly change into 2 different types of lighter particles, but when scientists looked at the data from the LHC, they found something surprising. The beauty quark didn't always change into those 2 lighter particles as expected. According to the standard model, which is sort of a big rulebook for how particles work, the beauty quark is typically meant to change into 2 different particles about half of the time. But the data from the LHC showed that it didn't. Instead, it changed into one of the particles called a muon much more often than expected. This unexpected result got scientists really excited. They think it might mean there's something new and exciting happening in the world of particles. The standard model of physics, which scientists have been using for a long time, might need to be updated. This could help answer lots of questions that scientists have been wondering about for a long time. The standard model is similar to a guidebook for understanding how everything in the universe works, but if there's something new out there that doesn't fit into the standard model, it could change everything. So, the data from the LHC isn't just a bunch of numbers. By studying this data, scientists might uncover new secrets about the universe and how it works. It's an exciting time for physics, and who knows what amazing discoveries lie ahead. It's pretty amazing how accurate the standard model of physics is. Scientists have used it to understand so much about how the universe works, but even though it's really good, there are still some things missing. The standard model only tells us about 3 of the fundamental forces in the universe: the electromagnetic force, the strong force, and the weak force. It doesn't explain gravity, which is what keeps us on the ground, or dark matter, which makes up most of the universe. During recent experiments at the Large Hadron Collider, scientists found something that didn't fit with what they expected. This happens sometimes, but this time it was very interesting. There was something different about the data they were looking at, and scientists wanted to find out what it was. To explain this strange discovery, scientists came up with a new idea. They think there might be a whole new basic particle out there that we've never seen before. They call it the Z-prime. This new particle would be so weak that we've never noticed it until now. But even though it's weak, it could still interact with other particles in a different way than we're used to. The researchers think that the Z-prime particle might interact differently with electrons and muons, which are 2 other tiny particles. However, they're still not sure how it would interact with all the other particles that we already know about. There's still a lot to learn about this new idea, and scientists are excited to keep studying it. So even though we've already learned a lot about the universe, there's still so much more to discover. The possibility of discovering new force-carrying particles is something that Elon Musk has commented on. Discovering new particles that carry forces would be life-changing in the world of physics. It's something scientists have been hoping for a long time. If they find these new particles, it could help them understand a lot of things about the universe that they don't understand yet. For example, they could finally figure out what dark matter is and learn more about the Higgs boson, which is very important in how the universe works. Some scientists think that if they discover these new force-carrying particles, it could help them do something really important: unify all the basic forces in the universe. That's something physicists have been trying to do for 100 years. Elon Musk has had some interesting things to say about all this. He recently talked about the Large Hadron Collider. It's not clear if Elon is really adding to conspiracy theories or just joking about them. The billionaire has used X, formerly known as Twitter, to talk about CERN's demonic technology. We all know Elon Musk is a forward-thinking leader in science and technology. For many years, he has been very interested in tech that could change the world. He likes trying new things and isn't bothered by criticism that comes his way. But what we don't know is what Elon has in mind to do with his post on X. He didn't say what he plans to do with the collider or why he wants access to the technology. Elon Musk has been known for his interest in groundbreaking technologies and advancements that push the boundaries of science and engineering. He's particularly focused on space exploration with SpaceX and advancements in electric vehicles with Tesla. His comments about CERN and the Large Hadron Collider, while sometimes provocative, likely stem from a genuine curiosity about scientific endeavors and their potential impact on humanity's understanding of the universe. Regarding CERN's operations and the Large Hadron Collider, it's essential to separate scientific exploration from conspiracy theories. CERN's experiments are conducted with rigorous safety protocols and are peer-reviewed by the global scientific community. The discoveries made at facilities like the LHC have expanded our understanding of particle physics and cosmology, contributing to advances that benefit society as a whole. As we look forward, the field of particle physics continues to evolve with ongoing research aiming to uncover new phenomena and further define our understanding of fundamental forces and particles. Scientists worldwide collaborate on these endeavors, sharing data and insights that propel scientific progress. In conclusion, while discussions about CERN and the LHC may sometimes be sensationalized, it's crucial to appreciate the significant contributions these institutions make to scientific knowledge and technological innovation. Elon Musk's interest in these areas reflects a broader curiosity about the universe and the potential for groundbreaking discoveries that could shape our future understanding of physics and beyond. The Large Hadron Collider, LHC, operated by the European Organization for Nuclear Research, CERN, stands as a pinnacle of human scientific achievement, pushing the boundaries of our understanding of particle physics and the universe itself. Situated beneath the Franco-Swiss border near Geneva, Switzerland, this colossal machine represents the culmination of decades of international collaboration and technological innovation. The primary purpose of the LHC is to accelerate protons and other particles to near-light speeds within its 27 kilometers ring and then collide them under controlled conditions. These collisions produce energies unseen elsewhere on Earth, allowing scientists to observe and study the resulting subatomic particles and interactions. Such studies are critical for unraveling the fundamental forces and building blocks of the universe. One of the most significant discoveries made possible by the LHC is the Higgs boson, famously confirmed in 2012. This elusive particle, predicted by the Standard Model of particle physics, helps explain how other particles acquire mass. Its discovery was a monumental achievement that validated decades of theoretical work and solidified the understanding of the Higgs field, which permeates the universe and gives particles their mass. Beyond the Higgs boson, the LHC continues to generate data that challenges and expands our understanding of fundamental physics. For instance, ongoing experiments aim to detect rare processes or new particles that could hint at physics beyond the Standard Model, such as dark matter or supersymmetric particles. These endeavors are crucial as they could provide answers to some of the most profound questions about the nature of the universe. The operation of the LHC involves complex engineering feats. Magnets cooled to near absolute zero temperatures guide the particle beams along the circular tunnel, while detectors like ATLAS and CMS capture the debris from collisions. These detectors are marvels of modern engineering, comprising millions of sensors and sophisticated electronics capable of recording vast amounts of data with precision. Data handling at the LHC is another remarkable aspect of its operation. The collider generates petabytes of raw data annually, which is processed and analyzed by a global network of scientists and computing centers. Advanced algorithms and computational techniques are employed to sift through this deluge of data, searching for rare events or deviations from expected outcomes that could signify new physics. The international collaboration behind the LHC is also noteworthy. Scientists from over 100 countries contribute to and benefit from experiments conducted at CERN. This diversity of expertise and perspectives enriches scientific discourse and accelerates discoveries as researchers share insights and collaborate on analyzing experimental results. Critically, safety is paramount in the operation of the LHC. Concerns about catastrophic scenarios, such as creating black holes or disrupting the fabric of spacetime, have been extensively studied and dismissed. Theoretical and experimental evidence supports the safety of collider experiments, reaffirming that the energy levels involved are far below those naturally occurring in cosmic rays striking Earth. The societal impact of CERN's research extends beyond pure scientific discovery. Technological innovations developed for the LHC have found applications in diverse fields, from medical imaging and material science to computing and telecommunications. Spin-off technologies, such as grid computing and advancements in superconductivity, have revolutionized industries and everyday technologies. Public engagement and education are also integral to CERN's mission. The organization actively promotes science literacy and outreach programs worldwide, inspiring future generations of scientists and fostering a deeper understanding of complex scientific concepts among the general public. Events like CERN's Open Days attract thousands of visitors, offering them a glimpse into the world of cutting-edge research. Looking ahead, the future of particle physics research at CERN appears promising. Planned upgrades to the LHC, such as the High Luminosity LHC, HLLHC, aim to increase collision rates and enhance sensitivity to rare phenomena. These upgrades are expected to further advance our understanding of particle physics and potentially uncover new mysteries of the universe. Moreover, CERN's role in global scientific cooperation remains indispensable. Collaborative efforts continue to push the boundaries of human knowledge, addressing fundamental questions about the cosmos and laying the groundwork for future discoveries. The pursuit of scientific excellence at CERN exemplifies humanity's collective curiosity and quest for understanding, transcending national boundaries and fostering a shared vision of scientific progress. In conclusion, the Large Hadron Collider and CERN represent a testament to human ingenuity and collaboration on a global scale. From the discovery of the Higgs boson to ongoing efforts to explore new frontiers in particle physics, CERN's research continues to shape our understanding of the universe. As we continue to delve deeper into the mysteries of particle physics, CERN stands as a beacon of scientific excellence and discovery, paving the way for a future where our knowledge of the cosmos is richer and more profound than ever before.